Okay, in this lesson, we're going to look at some additional geometry vocabulary. Okay, first of all, we have a radius. Okay, and a radius is a term that refers to the distance from the center of a circle to the edge of the circle. So maybe this distance right here, we would call the radius, okay, or r. So this distance is the radius. Notice that on a circle, there's an infinite number of radii, right? This is a radius. This is a radius. The cat just jumped onto my computer. Whoa, sorry. Cats are hissing all around me. I apologize. And so, like I was saying, there's an infinite number of radii. Okay, so that's what a radius is. Let's go on to the next one. Next is a chord, and again, on a circle here, we got the center. A chord is a line segment from the edge of a circle to another edge of the circle, right? So this right here is a chord. Okay, but notice there's many different chords that are possible. This is a chord. Notice that this is also a chord if it goes through the center of the circle. Okay, so all of those are chords. The next term is a diameter. Okay, and on a circle here, we got our center. The diameter goes through the center of the circle and touches either side of the circle. Okay, so this right here is going to be your diameter. Okay, just notice the relationship between a diameter and radius. This right here is a radius. This right here is radius. So 2 radius, right, is equal to 1 diameter. Cool? Okay, next one. Oops. A tangent line, tangent point. Okay, so this is another term on a circle. And here we have our center. A tangent point is a point that is on the edge of the circle. See that? And a tangent line is a line that goes through that point and does not touch the circle in any other places. Do you see that? So it's like it only touches the circle in that spot. Note, here's the rule. At this tangent spot, if you to the radius, right, this forms a 90-degree angle. Okay, let's maybe just draw one other circle and one other tangent, point and tangent line. So here's our circle. Here's the center. Let's actually put this just right here. Okay, here's the center. This tangent line would come right like that. Okay, so this right here, we refer to this as a tangent line. Okay, and then this point right here, I'll label it up here. This is a tangent point. So just a second, the cat's eating oatmeal. Just a second. Okay, next up. Concentric circles. Now, I'm going to just pull up a regular circle maker for this. I think it's just going to be easier to show you. Concentric circles. Oops, that did not work. Concentric circles are circles that share a center point, but have a different size radius. So let's give you one circle, for example, right? Okay, there's one circle. A concentric circle would have the same center point, but a different size radius, right? So these guys are concentric circles. We could add in as many concentric circles as we would like. You got the idea, right? They share this point. They share the center. Cool. And then this is the last term, arcs, major, minor, and semicircle. So on a circle here, I'm going to make this one nice and big. Here we got our center point. When we talk about arcs, the first one is a minor arc, and this one's a small one. Okay, so an example of this is maybe you would have this point A and this point B. The arc would be this distance, right, on the edge of the circle. Okay, and we would refer to this as arc AB, and we write it like this. We put AB with kind of this curved line at the top. Cool. That's a minor arc. A major arc is going to be greater. This is going to be a large arc, okay, or greater than 180 degrees. So this is A, B, and let's put another point over here, C, right? So this arc, I'm gonna put it in red here, maybe something like this, right? This arc from A to B to C, right? We would call that arc A, B, C, right? And that's going to be a major arc, right? Because it's greater than 180 degrees. Okay, and lastly, a semicircle, right? A semicircle is half of a circle, right? So let's add in another point here, A, and let's add in this point over here. Let's call it D. Cool. So we have A to D. So this arc right here, and I'll highlight it in black, right? We would call this arc AD. And arc AD is a semicircle, right? Because it's greater than it is 180 degrees. Cool. All right. So I think that's it. That's it. Thanks for watching. Okay, the last topic we're going to talk about is angle relationships. And what we mean here are the relationships that come up when we have two parallel lines. So I'm going to get two parallel lines here that are intersected by another line. Okay. So the way we label parallel lines is by putting these arrows on the two lines. Right? So those arrows signify that these two lines are parallel. Okay. This line right here, this has a special name. That's called a transversal. Okay. And so there's all these angle relationships that come up when you have two parallel lines intersected by a transversal. I'm going to go ahead and label some of these angles here. We're going to call this one 1, 2, 3, 4, 5, 6. Call this one 7 and 8. Okay, and we want to come up with examples of a bunch of these different angle relationships. Okay, so the first one that comes up are vertical angles. Okay, and for vertical angles here, there's lots of different examples, but remember the opposite sides of an x. So like 1 and 4 would be examples of vertical angles. 2 and 3 would be an example. Coming down here, 7 and 6 would be an example. And then, 5 and 8 are vertical. Got it? Okay. The next one are alternate interior angles. I'm going to move this just over a little bit. So, for alternate interior angles, we want to look inside the parallel lines, right? So we're looking inside the parallel lines, or interior, and then on opposite sides of the x, right? So this, you can think of this opposite and inside. Okay, so what we're talking about here, for example, is 6 and 3. Okay, and those angles are equal. Okay, so let's write up that example. We're talking about 6 and 3. Okay. Another example, right, would be 4 and 5. Cool. Okay. Next, a couple more here. We have what are called alternate exterior angles. alternate exterior angles. And so here we're looking outside of the parallel lines. So we're looking this way of the parallel lines, right? Or exterior, and then opposite sides. So here we're looking at, right, so like 2 and 7 would be alternate exterior. So we can write that up as an example. 2 and 7. And then also notice 1 and 8. Okay, so that's another example, 1 and 8. Okay, and the last one that we're going to cover is called corresponding angles. Oops, scroll back up there. Corresponding angles. Okay, corresponding angles are in the same position, right? So an example of corresponding angles would be this one, 2, and this one, 6. Okay, so like we're talking about 2 and 6. Okay, and there's lots of different corresponding angles, right? What about if we used 4 and 8? Right, so we'll put that one up there. 4 and 8. And then over here, if we come over here, what about if we used 3 and go to the same spot, 7. Right, so 3 and 7. And then lastly up here, 1 and go to the same spot, 5. Cool. And so that's kind of what we're looking at with angle relationships here. Okay, that's it for the video. Thanks for watching.